So I'm going to go over this warm-up because it's our last practice before the mini check. So you're welcome to use this to check your answers and maybe even clear up any final questions or confusion. So number one, f of, basically finding the value of the function, finding the y value. Remember, this is x, but the answer to this problem is going to be the y value when x equals a half. So x equals a half, probably either right here or maybe better yet about right here. I would give you credit for either one. Let's use the second one. That looks a little bit more like x equaling a half. And so it looks like y equals negative a half. That's the y value of this point. Again, negative 1/2. How about f of negative 3? We're just looking for the y value at negative 3. So this is when x equals negative 3, and it looks like the y value is negative 2. So f of negative 3 equals negative 2. F of 3 plus f of negative 3, that's just going to be two y values added together. F of 3, we can actually see, is 2. F of negative 3, remember, we already decided, is negative 2. So we got two y values. We're going to add them together. 2 plus negative 2. Your final answer being 0. And then this one is 7 times f of negative 2. Negative 2 is the x value. So I want to go to x equals negative 2. Find the y value. I'm pretty sure that y value is negative 1. Again, the y value is negative 1. But we're going to multiply that by 7. So we end up with negative 7. Domain and range. Remember, domain is just the furthest reaches of the x values. Should I look to the furthest left point on the graph? I sure should. But when I look to the furthest left value, I see the graph keeps going left to negative infinity. The furthest right value, that is the furthest x right value, is 3. So we're going to go from negative infinity to 3. The range is the y value. That is the furthest reaches of the y value. My graph keeps going down to negative infinity. My graph goes as high as 2. So I'm going to be from negative infinity to 2. That's the y value. Extrema. Extrema are like maxes and minimums, and some of them are absolute and some of them are relative. What do you think? You should feel like that this point up here is the absolute highest point, absolute maximum at 3, 2. How about this point right here? It's also a maximum, but it's not the highest point, so it's a relative maximum. Now, the point down here is a minimum, but it's not the lowest point because the graph keeps going down to negative infinity. Since it keeps going down to negative infinity, there is no absolute low point, but there is there is a relative minimum, and that would be this 1, negative 2. It's relatively a low point. Increasing. Remember, increasing means graph goes up. Graph is going up when from left to right, I climb. So the graph is going up from left to right when I'm climbing. Now I want to give that answer as an interval. In other words, where did this start? Well, it started left to negative infinity, but it went the whole way to x equals 0. Be careful. Make sure you're using the x values to describe the interval. And then my interval goes from 1 to 3. So I use the x values to give these two increasing intervals and not the y value. Now the graph is decreasing when we go down. And when we go down, that would be from left to right, this section. We just want to give it as the x values. X equals 0 to x equals 1 is that purple region when it's going down. So we can say 0 to 1. Now notice I don't use brackets because at the moment that I'm equal to those points, I'm neither increasing or decreasing. Roots. Roots are the x-intercepts. X-intercepts are these blue dots, but we give them as x values. So the first x value on the left is -1. The next one looks like it's pretty close to a half, maybe not exactly a half. Honestly, it's probably more like a third. Doesn't really matter. And then the last one is 2. Those are your roots. How about positive and negative? Positive just means that the graph is up in a positive place. In other words, it's got a positive y value. These two blue sections represent positive places. And notice that the roots become the interval, or at least the endpoints of the interval. So my first one here goes from -1 to 1/3. That's going to be my first interval. My next one looks like it goes from 2 up to the last x value, which is 3. So when I say 2 to 3, I'm describing that other blue region. Decreasing, or excuse me, less than 0 means the graph is negative. Less than 0 is these two red sections. Using the x value, my furthest x value to the left is -infinity, and then it goes up to the x value of -1. And then my x value from this point to this point is 1/3 to 2. Again, I use the x value to give the interval.